In the world of ion channels, there's an oddball. It looks like a channel and does a channel's job, but at heart it's a pump. It's called CFTR, and its story is the textbook case of the word undruggable being completely overturned. First, what it is. CFTR is a chloride channel, yet it belongs to the ABC transporter family proteins that are supposed to be pumps, hydrolyzing a TP to move cargo. Evolution rebuilt it into a gate. Two nucleotide binding domains clamp a TP like winding a spring, briefly opening the pore to let chloride out of the cell. Chloride leaves, water follows, and the mucus lining the airway, pancreas, and gut turns thin and slick. This pump-turn gate is the master lubrication switch of every secretory epithelium in the body. What happens when the switch breaks? The most common mutation is F508, del a single phenylalanine lost at position 508. That one missing amino acid makes the CFTR protein misfold, and it's destroyed as defective before it ever reaches the cell membrane. No gate at the surface, no chloride out, no water out, and the mucus turns thick and sticky. Airways clog and get infected again and again. Pancreatic ducts jam. This is cystic fibrosis, one of the most common lethal genetic diseases in the West. The real miracle is the drugs. If the fault is misfolds plus won't open, you attack on two fronts. Correctors help the misfolded protein fold properly and reach the membrane. Potentiators make the gate that did reach the surface open more often and release more chloride. Vertex combined 3 molecules into one cocktail ivacaftor plus 2 correctors called Trikafta. It covers about 90% of patients, turning a disease you rarely survived into adulthood into a chronic condition, managed with a daily pill. That one cocktail sells for over $10 billion a year, but all of it must first pass patch clamp and functional assays. How do you measure CFTR current? Classically, the Wu-Sing chamber measures transepithelial chloride current across a whole cell layer. More finely, patch clamp records single-channel openings directly. And closest to the patient, you grow the patient's own cells into organoids. Intestinal organoids swell when they meet a potentiator, and how much they swell reads out whether this drug works for this patient. Every screening step, correctors, potentiators, cocktail ratios rides on this chloride current readout. CFTR became the industry's template because it proved one thing. No matter how hard the channel, once you know exactly which step is broken, you can drug it. Today, next-generation CFTR drugs for rare mutations and new potentiator mechanisms are still coming, and each must be validated in functional assays for whether it truly lets chloride out. Whoever can reliably measure CFTR chloride current and run the organoid swelling assay holds the ticket to this $10 billion arena. Recap: CFTR, a chloride channel rebuilt from an ABC pump, is the lubrication switch for the body's mucus. F508 del makes it misfold and miss the membrane, causing cystic fibrosis. And the corrector plus potentiator cocktail rewrote a lethal disease into a chronic one, the #1 case of undruggable overturned. It tells us whether a channel can be drugged is often hidden in the patch clamp current. Next time, another red-hot target, the Kv7 potassium channel, the brake on neuronal excitability where new epilepsy drugs are piling up. Follow Ion Channel Observatory, one channel at a time.